So next topic we are going to see, that is atomic physics. And normally that any gas column or like air at an ordinary pressure, at a normal room temperature and pressure, will behave like a very poor conductors. So it is not possible to conduct electricity through a gas or air at normal pressure. But the scientists were actually trying to make that those gaseous column or air column to conduct the charges of electricity by some mechanism. But what other mechanism can be applied to those gaseous columns so that the gaseous column or air column can be made to behave like a conductance of electricity? So the two important mechanisms were adopted. One, by applying a very high potential at a low pressure of a gaseous column, one, and second one, at the same time, and the X-ray must be passed through the gases. So I repeat, the two important points I repeated. One, high potential difference must be applied across a gas column at a very low pressure, and second point, by applying the gas or the X-ray can be allowed to pass through the gaseous column, that particular gas column will start conducting electricity through it. So these are the two mechanisms with which any gas column can be made to conduct electricity. And this particular idea and create a new invention regarding that the structure of an atom. The first one, the same discharge of electricity through a gas, so that the electron was discovered by J.J. Thomson discharge electricity tube. The diagram which is drawn on the board is that discharge tube, electricity discharge tube designed by J.J. Thomson, whose length is about 50 centimeter and in diameter of 4 centimeter. And which has got this is a very strong glass. The whole discharge tube is made up of a very strong glass containing cathode and anode, and these two cathodes are connected to the very high induction coil, across which we can apply 50,000 voltage. Imagine high voltage can be applied. 50,000 voltage can be applied across the cathode and anode. And also, this strong discharge tube is fitted with a high evacuation pump with a gauge meter. So we can, with a gauge meter that is not actually shown in the diagram, we can able to measure the gas, what's called the pressure of a gas enclosed within the discharge tube. So by reducing the pressure, so any amount of gas, any gas can be enclosed within this strong glass tube, and when the pressure within the glass tube is maintained at 110 millimeter of Hg. So first one, when the pressure is maintained within the discharge tube at about 110 millimeter of Hg, J.J. Thomson observed nothing actually, no electricity is actually produced. When the pressure is dropped down from 110 to 100 millimeter of Hg, and he saw that the irregular streaks of light accompanied by a crackling sound, and it was actually is present within the glass tube, within the discharge tube. Then when the pressure is still further reduced to a 10 millimeter of Hg, the irregular streaks broaden out, and which starts from anode and up to the cathode, extending up to the cathode. So it was actually the entire luminous column. He saw the entire luminous column starting from anode up to the cathode, and so this has happened at the pressure of 10 millimeter of Hg. So in the fourth time, when the pressure is further reduced from 10 to 0.01 millimeter and Hg, the luminous columns starting from anode and extending up to cathode disappeared completely, and in that place darkness was actually produced. That darkness space was named by him as a Crookes space. because Crook is the name of, is a close friend of J.J. Thomson. He helped him for this particular experiment. So in order to honor him, he named this space called dark space at the pressure of 0.01 millimeter of Hg as a Crook space. At the same time, the discharge tube surrounding the cathode or nearby the cathode was fluorescing with a greenish glow. So the final stage of a greenish glow must be the reason due to that a small tiny particles emitted from the cathode, emanating from the cathode, must strike the discharge tube. That is why this particular discharge tube was fluorescing with a greenish glow. So then later on, when he analyzed that tiny particles, they are nothing but electrons, they are called cathode rays. The rays which are coming from cathode must be the cause for this discharge tube to glow in greenish color. So he finally comes to the conclusion that the final glow of a discharge tube is due to some amount of particles which are emanating from cathode. They were named as cathode rays. But finally he concluded those cathode rays are simply nothing but the electrons. So this is how the story goes. The invention of discovery of electrons using that discharge tube by J.J. Thomson experiment. But now we have to go to the properties of the cathode rays. The cathode rays are nothing but electrons. It has got high energy, momentum, it affects photographic rate. Whenever it falls on certain metals, it produces fluorescence, and then it can be deflected both electric and magnetic field. It travels 1/10th of the velocity of light. It's nothing but one of the constituents of the atom called an electron. So these are the important properties. You can list it out. So property alone can be asked in 5 mark questions, and the experimental setup with the discharge tube can separately be asked in 5 mark questions. Next we will move on to another experiment done by the Goldstein, is a German scientist, and he found that he discovered that canal rays. The canal rays is otherwise called a positive rays. So he designed a tube called, he particularly designed a tube and this is called anode, and the screen S is kept on the right extreme, and exactly not at the center, just in front of the center, he kept a cathode as a perforated metallic circular disc. What do you mean by perforated metallic circular disc? Can you tell me? It's nothing but a metallic circular metal which is in the circular shape having some holes in it. It's called a perforated metallic circular disc, and this acts as the cathode. So between anode and cathode, high potential was applied by him, and so as studied in the previous discharge electricity by J.J. Thomson experiment, at one particular higher potential, so discharge is taking place, and then when the pressure inside the gas is maintained at 1 millimeter of Hg, what happens? The discharge takes place. The cathode rays normally will start from cathode and extending up to anode. So everybody knows it. This is what we have understood from the J.J. Thomson experiment. But at the same time, behind the perforated metallic circular disc, a stream of particles are moving from the cathode rays towards the screen behind the cathode. So the cathode rays are actually moving from perforated metallic circular disc to anode. These are called the cathode rays. But at the same time, behind the perforated metallic circular disc, the stream of particles are moving from the cathode towards the screen. So it is understood that, so he just viewed these rays of particles, and Goldstein and Einstein immediately declared that these particles are actually moving opposite the cathode rays, because everybody knows that the cathode rays is nothing but the electrons, and these particles must be the positive particles. So since they are coming out from the small holes, he initially called these particles as the canal rays, and later on he called that as a positive rays. Why? Because they contain a positive charges. which are moving opposite the direction of the cathode rays, then he called by other name as the canal rays or positive rays. And what are the properties of the positive rays? So these particular the positive rays and the explanation along with the discharge tube can be asked in 5-mark question, but another 5-mark question can be asked from this area stating that listing out that the properties of the canal rays or positive rays. So each and every particle whose mass is equal to, each and every particle can be considered as the ion. So mass of the ion is equal to mass of the atom of the gas enclosed. And second, as we have seen earlier, as the cathode rays affect the photographic plate, and whenever it falls on certain metals, some fluorescence is pretty similar to that. It affects the photographic plate. Positive rays affect the photographic plate, can be deflected by electric field and magnetic field, and then whenever it falls on the certain metals, produce a fluorescence, and when they pass through the certain gas, that particular gas can be ionized. So all these things. But when you compare the velocity of cathode rays and the positive rays, the velocity of the cathode rays is about 1/10th the velocity of light, correct? But in the case of the positive rays, the velocity of the positive rays bit lesser than that of the velocity of the cathode rays. So we can't able to find out and what's the speed with which it will travel. But in general we can say that the velocity of the canal rays or positive rays will be definitely lesser than that of the velocity of the cathode rays. So these are the differences between the properties of the cathode rays and the canal rays, called positive rays and cathode rays. But the most of the properties of the cathode rays and the canal rays, positive rays, are similar except 2 points. The next we will move on to the determination of the specific charge. It is shortly called as ratio of the E by M. That is ratio of the charge of an electron to the mass of the electron. This is a very important 10-mark question. Can be repeatedly asked. It was asked repeatedly in the board examination. So determination of specific charge. Specific charge, in bracket we can say E by M by J.J. Thomson. So first I am going to explain about what is meant by specific charge. The charge per unit mass of an electron is simply called specific charge of an electron. This specific charge of an electron is independent of gas enclosed as well as the nature of the electrodes which are used in the discharge tube. And now we are going to see the principle. What is the principle of this particular experiment? So the deflection property of a cathode rays, when they are subjected to the electric field and the magnetic field, is the principle of this particular experiment. And we will see the construction. So in order to understand the construction, I am going to draw the diagram. Just follow the diagram. So this is a discharge tube designed by J.J. Thomson to calculate the E by M method, E by M value. So here is an anode and there are 2 diaphragms, D1, D2. This is the cathode. D1 and D2 are the 2 diaphragms are behaving as the anodes. When these 2 diaphragms in the anode and cathode, when they are maintained at a very high potential difference from the surface of the cathode rays are emitted. The emitted cathode rays are accelerated by the 2 anodes. They are nothing but diaphragms. So when the electron beam entering into the 2 small holes of the diaphragms, it is converted into fine thin pencil of a ray of electron beam. So the electron beam is converted into thin pencil of ray, and then it is traveling in straight line and hits on a flat screen in which some fluorescence coating is provided. So a bright dot point is produced called a Q. So this is a very simple arrangement. One can